Alright, so I'm going to tell you guys a little story. Okay? So, not true, but it's going to help you guys remember how to measure. Okay, so it's going to be a little story, kind of something there to jog your memory and add a little bit of logic to the way why our ruler is the way that it is. So, there were two guys, okay, long time ago, like, I don't know, 1,000 years ago or something, right? And they're sitting around their kitchen, they're like, hey, you know what, it'd be really cool if we had a box up on the wall, out of the way, that we could store our cups in, you know? Because when we just leave our cups out on the table, you know, they get dirty because, you know, there's like, you know, dust settling everywhere. It's like 1,000 years ago, right? It's like dirty, right? So, flies get on the stuff, right? And they're like, man, we should put a box up on the wall and put our cups in there and, hey, we'll call it a cupboard. Perfect. All right. So, the guys said, well, let's build one. They built one. They put it up on the wall and they loved it. It was great. And the guy's like, hey, we should build another one because this was pretty cool. They built another one, but they weren't the same. You know, they were different sizes. They're like, it'd be really nice if they're both the same size, but what could we do to make them the same size? The guy's like, I don't know. What do we do? It's like, well, why don't we take a stick and then we can, you know, put it up on one side of the board and then we'll mark it where the other side of the board ends, and then we'll just keep doing that for all the boards. The guy's like, man, that's a lot of sticks. Maybe we had one stick that had marks on it in specific places. You know, we could use that to measure these boards so we'd know where to cut them and where to mark them and stuff like that. And the other guy's like, that's genius. Okay? So then they came up with this idea of having like a ruler or a yardstick, okay? Or a tape measure type thing. So what they did is they took a board and they put marks on it. And they put marks about every inch. Now right here on you guys, that's about an inch. Okay, from right here to right here, that's about an inch. A little bit more than an inch on me, I'm 6'4", right? Pretty big, a little more than an inch, right? Okay, so they came up with that, and they said, well, about how many of these goes in your foot? We'll just call it a foot, you know? Okay, well, about 12 of them go in your foot. Perfect, all right. So then they had 1 foot, right? There's 12 inches per foot. So they just filled out this stick with a bunch of marks, okay? 1 mark every inch, and here is an example section of their ruler. This is the first part, 0 to 1. Okay? So they had this part on the ruler laid out. Of course, it was a lot smaller, but I'm drawing it big so you guys can see it. And they started measuring these boards. They realized that some of the boards didn't end exactly on the 0, and some of them didn't end exactly on the 1, and the 2, and the 3, and the 4. Now, obviously, none of the boards ended on 0 because they wouldn't exist, right? But okay? So they realized, well, we need to do something different. The guy said, well, this board ends about somewhere in the middle. So they drew a line in the middle of the 0 and the 1, and between the 1 and the 2, and between the 2 and the 3, and they called that a ½ inch, right? Because here's your whole inch, and here's your ½ inch. Okay? And the guy goes, well, yeah, that's great, but what if it doesn't land on the ½ inch? And the other guy goes, well, then, you know, we'll just add another line. Divide that half into half, and you get quarters, right? A half divided by a half is a quarter. All right? The guy says, this is foolproof, man. It works. And the other guy goes, well, what if it doesn't end on the quarter or the half or the whole? What do you do? I mean, this isn't going to work. So what they did was they decided to, hang on, hello. Yeah, if they could, they'd just stack them outside my door. Yeah. Yeah, I'll take them all. Yeah, awesome. Just tell them to put them outside my door. All right, thanks. Bye-bye. All right, so what they decided to do was just divide the quarters in half. And it worked. And the guy goes, this system is genius. We can just keep dividing these sections in half. All right, so after the eighths, so now you got eighths, right? Divide a quarter in half, you get eighths. Divide an eighth in half, you get 16ths. All right? So, you can keep going. So what comes after a 16th? 32nd, right, perfect. And after a 32nd, 64th. And after a 64th, 128th. And after 128th, 264. Or 56, 256, right. Yes, 256, good. That's where the 256-bit encryption comes from. It has something to do with that, okay? Because you got like the zeros and ones, right? And you get so like strings of 8 gives you a bit. Anyway, all right. So you're back to this. But the guys are like, man, now we got this stick. It's like this long, but it's just full of lines. You can't read it. You know, if you measure a board and it ends right here, how do you know what size measurement that is? You know, you got to count them. It should be easier than that. So the guy said, you know, why don't we make the lines different sizes? If we make them different sizes, then you can look at them and you'll know immediately which size, which measurement each line is. But you can't just go like smallest to biggest. You know, you can't just make this one smaller and this one a little bit bigger, and this one a little bit bigger, a little bit bigger, a little bit bigger, because that's not going to help you. All right. So he said, let's make all of the 16th measurements the same size. So every other one was a 16th measurement, right? So they made all the 16ths smaller. Right? And then the next smallest, the next bigger line would be the 8ths, right? So the 8ths are also every other line. Okay? And then the next one is your quarters, right? And then you have the big one, which is your half, and you have that. And does that look familiar to you guys? Yeah, pretty cool, huh? Yeah. Yeah. So, now, I'm going to erase this, and I'm going to show you guys how I draw this. All right? Hey, guys, just stack them up outside, all right? Thank you. All right, so what I'm going to do is I'm going to show you guys how I lay out those lines, all right? Now, this is the easiest way to lay out the lines, all right? So I suggest that you guys do it the same way I do. All right, so what you're going to do is you're going to make that upside down bracket, right? Just like that. Okay? And then you'll draw a big line in the middle, because everybody can find the middle, right? It's pretty simple. All right, and then you're going to divide those two sections in half with a line that's not quite as long. Okay, and then you're going to divide those sections in half with a line that's not quite as long. Okay, and then you're going to divide those sections in half with lines that are tiny. Okay. Cool. Now, if you can remember that all those tiny lines are 16ths of an inch, that's like half the ruler. Okay, that's pretty darn good. So, let's lay these measurements out. So you got 16ths up here. So you got 1 16th, 3 16ths, 5 16ths, 7 16ths, 9 16ths, 11 16ths, 13 16ths, and 15 16ths. Now those numbers have some things in common. What do those numbers have in common? Yes? They're all odd. Yeah, all the numbers on top are odd. Okay, so they all have odd numerators. Numbers on top are odd. Good. All right, who can give me another one? Give me another. What else do those numbers have in common? Yes?
Oh, they're all numbers.
They're all numbers. Yes, they are all numbers. Yes. What else do you see in common? Yes?
They're all fractions.
They're all fractions? Yes, they are all fractions. That's very true. They are all fractions. So they all have a number on top and a number on bottom. Yes. All right, very good. What they aren't is decimals, okay? They're not decimals, okay? You're not going to see any of this, all right? 1.25 or 0.25 or 0.375, which is the decimal equivalent of those, okay? That's not how we read a ruler, okay? Good. What else do you know all have in common? Anybody else? Yeah, they all have the same number on bottom, right? They all have 16 on the bottom. So they all have the same number on the bottom. It's called the denominator, but I don't like big words. Okay? So they all have the same number on the bottom. All right, what else? Yeah.
They're all measurements.
They are all measurements. Yeah, they're all measurements on a ruler. That's good, yeah. So they're all measurements. All right. I don't know how to spell that word, so we'll just cross that out. All right. So, yes.
They all have the number next to them.
Um,
I mean, what? Yeah.
other thing that I think is just so obvious you guys probably aren't picking up on it. They go in order. Okay? They go in order. Okay? So 1/16 is smaller than 3/16. Okay? 3/16 is smaller than 5/16. Alright, now what is that order? Alright, they all increase by 2s. Okay? How many of you guys can't count by 2s with odd numbers? Perfect. I knew you guys could do it. Alright? Good. Alright, so they all increase by 2. Alright? So 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 2 is 15. Perfect, right? Alright? Cool. Alright, anybody want to take a stab at what this number is down here? Yes.
2/8.
1/8.
Oh, yeah.
Alright, perfect. You had it right the first time. Don't second guess yourself. Alright, good. Alright, so this pattern continues. Alright, it's the same pattern. Alright, so you got 1. So what number comes next? 3, 5, 7. Okay? You guys see that pattern? Alright. Cool. Alright, and then you got your 1/4 inch, 3/4 inch, 1/2. Alright. Cool. You guys got it? Make a little bit more sense now?